Okay, hello class. We're going to continue on today with more about Python classes. The last time, we kind of left off where we talked about how we can create our own new class, our own new data type. Just like a turtle, we can create, a turtle was a library that we used, and that turtle can do things. The other day we learned about how we can make our own class, our own data type, and so we learned about how we could create our own, say, bank account. This bank account is, you can visualize it like this, where the bank account has two things. It has some information about itself. It has an owner and it has a balance. And you see that over here, right? Self.owner, self.balance. So owner and balance. And it also had a few methods. Some getter methods, get owner, get balance, and also deposit. So this is a picture of our bank account. And so whenever I have a bank account, I could call any of these methods, and I could also access these state information, these state variables. Okay, so now we're going to extend on this, and we're going to look at some other special methods. Now, what I mean by a special method is the following. This is a special method. This is a method that actually allows us to create the bank account and to initialize it. We're going to learn some other special methods that allow us to do other things like printing, comparing to two bank accounts, adding, etc. So let's look at that. So the first one we're going to look at is the underscore str__ method. And so this method is going to be defined like such. It has just a single input, which is itself. And this method will be called whenever the string method is called or whether the print method is called in our code. And so this will allow us to create a string representation of our object. So like if I have a bank account and if I want to print my bank account, what does it mean? Down here, for example, I made a bank account. What does it mean to print my bank account? Python doesn't know how to print out your bank account. And so we need to tell Python, we need to give it instructions. If I want to print my bank account, what should it print out? If I want a string of that object, what should that string be? So this is where we get to define whatever we want. So we, inside of this class, we define this special method __str with this as the input. This is itself. And remember, self is the bank account itself. Self is a bank account, and self has an owner and a balance. So we can use the owner and the balance information to create whatever kind of string we want. And so I've chosen to do this. I'm going to concatenate a string together where I say my name, self.owner, has a certain balance amount. And you notice that I had to take this integer here and turn it into a string in order to properly concatenate. Now, important things to kind of understand. I'm returning here, not printing. Somehow, I think it's kind of a very common mistake to say that, oh, because this print method calls this string __ string method here, I'm going to put a print statement here. No, don't do that. This method must return a string for it to work properly, because the string method here, str, if I put s is equal to str of my account, I don't want this to call this and then print something out. I want it just to return a string. So make sure you do not print here. Make sure you return. And I also said return a string. So you need to craft up by, however you'd like, a message, a string that gets returned. So in this case here, when we create the bank account and we print out my account, it prints out this nice message here, Mark has $1,000. And it's kind of cool because I can customize my bank account to do whatever I want. Now, when we compare two objects, we compare two objects with an equal sign, right? Equal, equal. Now, let's see what happens when we do this. Okay, so poly 1, I create this object here, this rectangle object. Create poly 2, this other rectangle object. Poly 3 references this other rectangle object. Now, if I'm comparing is poly 1 equal to poly 2, what this equal sign will do is it's going to say, are the arrows pointing to literally the same object? And they're not. They're pointing to two different objects, and so we get false there. And in a similar way, poly 1, poly 3, they point to two completely different objects, so that's also false. Now, if I created another variable, poly 4 equals poly 1, then in this case, poly 4 is really just a alias of poly 1. And so the arrows point to the same object. So then if I say, is poly 1 the same as poly 4, and we print that out, we'll get a true because they are pointing to the same object. Now, this kind of equivalence checking is called shallow equivalence checking because it's all it's doing is determining if the arrows point to the same object or not. It's not looking inside the contents of the object. It's merely saying, do these arrows point to the same thing? And this is kind of maybe not what you would want in the case of a rectangle, because I have these two rectangles, and a 3x4 and a 3x4, you would think they should be the same. And in fact, you would think maybe even a 3x4 should be the same as a 4x3, that ideally both of these would evaluate to being true because they really are, at least mathematically, the same rectangle. They're equivalent. So we can define our own equality checking. We can give our own rule so that Python can do that equals correctly. Think about it. When we make a rectangle, Python doesn't know about the concept of a rectangle. We're creating it ourselves. We're telling Python that this rectangle has a side 1 and it has a side 2. But that's all it knows. It has no idea of how to kind of determine whether one rectangle is the same as another. We need to instruct it. We need to tell Python how to do equivalence checking between two rectangle objects. And so that's where this other special method class comes in. It's underscore underscore eq underscore underscore, and there's always two parameters to it because we compare two things. So we always compare ourselves to, typically this is the name of the other parameter, we just call it other. And it doesn't have to be named other, you can call it something else, but this is just kind of a nice little convention. These are the two objects that we are going to compare. Are these two objects equal? And this method is called whenever Python sees the equal operator. So this is what I mean. Down here you see, is poly 1 equal to this? What it's going to do is, it's going to check to see if we've defined this underscore underscore equal within the rectangle class. And so the nice thing about this is we can define equivalency however we would like. We could say that a 3x4 and a 4x3 rectangle are equal to each other. So let's see how we do that. So as I mentioned, this is the way we declare it. Two inputs going into this method. And equal and other, just know that these are both rectangle objects. So I know that when you look at these two words, you're just looking at them as just variable names, but you should understand that self is a rectangle. The rectangle has a side 1 and a side 2, so we have a self.side 1 and a self.side 2 that we can have access to. We can get information into that. Other is also a rectangle. And so other is also going to have these same attributes. There's going to be an other.side 1 and an other.side 2 that we can access. Okay? Yeah, so you have to think more broadly when you think of these two words, self and other. They're not just two variable names. They are object references that are of type rectangle. So let's look at it in this context here to understand it and visualize it a little bit. So let's suppose, going back to this previous example, that I made these three polygons here. Polygon 1, rectangle 2, rectangle 3 of these different sizes. And so if I'm going to check if poly 1 is equal to poly 3, when Python encounters the double equal sign, it's going to check to see whether or not there has been a method inside the rectangle class called equals, __ equal. And if it is, then we can do more kind of intelligent equality checking. So then it's going to call this method, and it's going to supply, it's going to plug poly into self, and it's going to plug in poly 2 into other. And so when we do that, because we're copying poly 1 into self, self ends up being an alias to this object here, and other ends up being an alias reference to poly 2. So self then points to this object, other points to this other object, and so now we can compare these two. So then we say if self side 1, and self, we could follow the arrow up here to size 1, is equal to other side 1, so we follow the arrow over here to side 1. If 3 is equal to 3, and if 4 is equal to 4, then they're equivalent. So in this case, it's true. Now we've also defined it where if side 1 of this poly is equal to side 2 of the other rectangle, then we could also handle the case of a 3x4 being the same as a 4x3. And so the second case is also true because we added this extra line down here to account for that situation. This is what we call deep equivalency because we're going inside. We're not just looking at the arrows. Do the arrows point to the same object? We're actually going inside and comparing attributes about the two different objects to see whether they are equivalent. And again, we, as the programmer, define whatever kind of equivalency we desire to have. I did not have to have this line underneath here. I could have just defined rectangle equivalency to being a 3x4 is equal to a 3x4 and not a 4x3. My choice as a programmer. Now there are other special methods that are available. We have adding, subtracting, multiplying, dividing special class methods. And so whenever Python sees the plus, it will look for this __ add. Whenever we use the minus operator, Python will look for the underscore underscore sub method. So let me give you a little example of this to try to illustrate. Suppose I have two rectangles, rectangle 1 plus rectangle 2. And so when Python sees the plus, it's going to look for the underscore underscore add. And when it does that, we need to add up two things. So when we define this method, we should give it a self and an other. Just like equals, we add two things, we compare two things. And so what Python will do is it will plug R1 into here and it will plug R2 into there. And just as we talked about earlier for the equals, underscore underscore equal, we could define adding to be whatever we want. And in the case of a rectangle, what does it really mean to add two rectangles? There really isn't a definition for adding two rectangles. But let's just suppose something silly, just for the example of illustration. Suppose I had two rectangles, and I want to add two rectangles. Again, this is not mathematical at all. It's just purely for illustration purposes. If I happen to define addition of two rectangles to be creating a new rectangle of size 8 by 10, where all I'm doing is adding up side 1 and then adding up side 2. Okay, so in this case, I'm defining it to say a rectangle plus a rectangle should be another rectangle. So how do we do that? Well, we need to return if rectangle plus rectangle equals rectangle, then we need to create another rectangle to return. So we need to create a rectangle. And how do we make a rectangle? Well, we call the constructor. The rectangle, we say create a rectangle, and we need to supply side 1 and side 2 values. And so we define this to be 3 plus 5. So we need to take self side 1 plus other side 1. And then the other side 2 is kind of analogous to that. Now, it might seem a little odd that inside of the class definition for a rectangle, you can call this rectangle constructor. So it might feel a little kind of funny to you. But yes, you can do that. You can make a rectangle inside of your rectangle class. Now, just to further this example of how I could define things however I want, maybe that's not my definition of addition of rectangles. Maybe when I add up rectangles, I'm just saying add up the area of the two rectangles. And in that case, I want it to be 3 times 4 plus 5 times 6 equals 42. So in this case, I just want an integer to be, or a number to be returned. So in that case here, I just customize it differently. In that case, I just say self dot side 1 times self dot side 2 plus etc., etc. Okay, so again, the emphasis I want to talk about is how I could define this method to behave however I want, so that in the code, when I say rectangle 1 plus rectangle 2, Python's going to say, oh, let me check to see if a special adding instructions have been given to me, and if this special add instruction has been given to me, then I will just follow it and do whatever it says to do. Okay, and so then we can give meaning to plus, minus, star, and divide for any sort of class that we make. Now, we might not want it in general, actually, for a rectangle, it probably actually doesn't make any sense to create any of these for rectangles, because what does it mean to add a rectangle to another rectangle? It doesn't have any meaning. So maybe for the rectangle class, normally we wouldn't really support this. We would not bother to define anything at all there. Okay. Anyways, that's today's lesson about special class methods. We'll continue on next time with a little bit more about Python classes. Okay? Have a good day, everybody.